What secrets hide in the darkest corners of the universe, where light itself dares not tread? Space, vast and unyielding, is more than a canvas of shimmering stars and endless possibilities. It is a realm of staggering beauty, yes, but also of chilling enigmas that defy reason. Picture this: a void so immense that entire galaxies seem like mere whispers within it, or explosions so powerful they could end civilizations before they even begin. Beyond the romantic notions of celestial exploration lies a truth far more unsettling, a universe filled with phenomena that terrify as much as they fascinate. In this journey, we will uncover 25 of the most harrowing mysteries of space, each one reshaping our understanding of existence and pushing the boundaries of human curiosity. Stay with us as we dive deeper into the cosmos, where both wonder and terror await at every turn. Now turning to one of the most haunting features of our universe, the Boötes Void stands as a staggering enigma, a cosmic cavern of nothingness. Spanning an almost incomprehensible 330 million light-years across, this void is not just empty space. It is a profound absence that challenges everything we know about the cosmos. To put its size into perspective, the entire Milky Way galaxy and thousands more like it could fit within this void with room to spare, yet there are only a few isolated galaxies scattered within it. Scientists have pondered why such an immense region of the universe exists with so little matter. Some theories suggest that smaller voids merged together over billions of years, creating this vast emptiness, while others propose it may represent a clue to hidden processes of cosmic evolution that we have yet to uncover. The Boötes Void raises unsettling questions. Why is this region of space so desolate? And what does its existence reveal about the larger structure of the universe? Could it hint at forces or phenomena we do not yet understand, or perhaps even alternate explanations for the way galaxies form and distribute themselves across the cosmos? It is a stark reminder of just how little we truly know, and how the universe in all its grandeur can also be uncomfortably silent. Moving forward, we encounter another cosmic phenomenon, one that roams the universe untethered and brings its own share of mysteries: the rogue planets. Moving forward, we delve into the mysterious existence of rogue planets, often referred to as the homeless worlds of the universe. These are planets that drift through the vastness of space, unbound by the gravity of any star. Unlike planets within a solar system that orbit their parent stars, rogue planets roam aimlessly in perpetual darkness. Scientists estimate there could be billions of these wandering worlds in our galaxy alone, a staggering number that hints at their significance in the grand design of the cosmos. But how do such planets come to exist? Many are thought to form within solar systems, much like Earth, only to be ejected by powerful gravitational interactions with other planets or stars. Others may have formed independently, never tethered to a star from the very beginning. Their isolation creates an eerie image, a world shrouded in endless night, where the only light comes from faint, distant stars or internal heat generated deep within. The conditions on these planets are likely extreme and inhospitable, with sub-zero temperatures and no consistent energy source to sustain life as we know it. Yet, some scientists propose that rogue planets with thick atmospheres or geothermal activity could potentially harbor life in hidden, unexpected ways. Beyond their potential for life, rogue planets also pose a significant threat. Should one wander too close to a solar system like ours, its immense gravitational force could disrupt planetary orbits, creating chaos on an unimaginable scale. These silent, nomadic worlds are a chilling reminder of the universe's unpredictability. With that thought lingering, we now turn to the colossal force lurking at the heart of our galaxy, a phenomenon that is as captivating as it is terrifying: the supermassive black hole known as Sagittarius A. Now turning to the supermassive black hole at the center of our galaxy, Sagittarius A stands as both a marvel and a menace within the cosmos. Located approximately 26,000 light-years from Earth, this colossal force boasts a mass equivalent to over 4 million suns, compressed into an area no larger than the distance between the Earth and the Sun. Its immense gravitational pull is the glue that holds our Milky Way together, orchestrating the dance of billions of stars in a complex cosmic ballet. Yet, this awe-inspiring giant is shrouded in mystery and danger. At its core lies the event horizon, a boundary beyond which no light, matter, or even time can escape. Anything that crosses this point is doomed to an unknown fate, forever lost to the singularity where gravity becomes infinite and the laws of physics as we know them cease to function. What makes Sagittarius a star particularly unsettling is not just its size, but its unpredictability. Though currently in a relatively quiet phase, it occasionally flares up, emitting bursts of radiation that can disrupt its surroundings. Scientists theorize that if a stray star or cloud of gas ventures too close, it could awaken the black hole's voracious appetite, triggering a feeding frenzy that would unleash devastating energy across the galaxy. Such events, though rare, highlight the volatile nature of this galactic centerpiece. Despite its terrifying qualities, exploring Sagittarius A star offers unparalleled opportunities to deepen our understanding of black holes and the fundamental mechanics of the universe. Advanced telescopes and simulations allow researchers to study its orbiting stars, providing crucial clues about the nature of space and time under extreme gravitational forces. The supermassive black hole at the heart of our galaxy is both a silent guardian and an eternal enigma. It shapes the Milky Way while reminding us of the sheer scale and power of the universe's dark side. From this monumental force, our journey now shifts to a phenomenon of cosmic destruction on an even grander scale, the collision of entire galaxies. Moving forward, we encounter a cosmic event so immense and chaotic that it redefines the very concept of destruction, the collision of galaxies. Picture two massive star systems, each containing billions of stars, hurtling toward one another in a gravitational embrace that will last for billions of years. Among the many examples of such events in the cosmos, none hits closer to home than the future collision between our Milky Way and the Andromeda galaxy. Currently separated by over 2 million light-years, these two giants are on a slow-motion collision course, drawn together by the relentless pull of gravity. In roughly 4.5 billion years, they will meet, and the result will be nothing short of apocalyptic. As the galaxies approach, individual stars are unlikely to collide directly due to the vast distances between them. However, the gravitational forces at play will wreak havoc on both systems. Entire star clusters will be ejected, flung into intergalactic space, while others will be pulled into new orbits. Gas and dust clouds, the building blocks of stars, will crash together, sparking intense bursts of star formation, brief periods of light and creation amidst the chaos. Meanwhile, the supermassive black holes at the centers of both galaxies will spiral toward each other, eventually merging in a spectacular display of energy that will ripple across the universe in the form of gravitational waves. This isn't just a story of destruction, but also one of transformation. Over time, the Milky Way and Andromeda will merge into a new elliptical galaxy, often referred to as Milkomeda. This new formation will have its own unique structure and characteristics, bearing little resemblance to the spiral galaxies we know today. For any civilization that might exist in the far future, the night sky would look radically different, a tapestry dominated by the remnants of countless stars and the scars of their tumultuous past. Yet, what makes galaxy collisions even more fascinating is their role in shaping the cosmic landscape. They are not rare anomalies, but rather a natural part of galactic evolution. These collisions have occurred countless times throughout the universe's history, acting as both destroyers and creators. They tear apart existing structures and pave the way for new ones, continually reshaping the cosmos in an endless cycle of death and renewal. As we reflect on the scale and magnitude of such an event, it's a stark reminder of the universe's dynamic and ever-changing nature. From this grand spectacle of destruction and rebirth, we now turn our attention to one of the most powerful explosions in the universe, a phenomenon that holds the potential to obliterate everything in its path: gamma-ray bursts. Now turning to one of the most cataclysmic forces in the universe, gamma-ray bursts. These are the most powerful explosions known to humankind, releasing more energy in a matter of seconds than our sun will produce in its entire lifetime. Imagine an intense flash of gamma radiation sweeping across the vastness of space, obliterating anything unfortunate enough to be in its path. These bursts are often the result of massive stars collapsing at the end of their life cycles, creating either black holes or neutron stars in the process. Alternatively, some gamma-ray bursts are thought to originate from the collision of neutron stars, an event so violent that it not only releases these deadly waves of energy, but also forges heavy elements like gold and platinum. The energy from a gamma-ray burst is emitted in narrow beams resembling a concentrated cosmic laser. If one of these beams were to directly hit Earth, the consequences would be catastrophic. The intense radiation could strip away our planet's protective ozone layer, exposing the surface to lethal levels of ultraviolet radiation from the sun. This would disrupt ecosystems, lead to mass extinctions, and fundamentally alter the planet's climate. Scientists even speculate that past gamma-ray bursts could have been responsible for some of the mass extinction events in Earth's history, although concrete evidence remains elusive. One of the most famous observations of a gamma-ray burst occurred in the year 1979, when astronomers detected an intense flash of gamma rays from a distant galaxy. Since then, advancements in technology have allowed us to study these phenomena in greater detail, and we now observe gamma-ray bursts regularly, providing clues about their origins and behavior. One striking example is the gamma-ray burst detected in the year 2008, known as GRB 080327b. It was so powerful that, despite occurring more than 7 billion light-years away, its optical afterglow was briefly visible to the naked eye here on Earth. While fascinating, gamma-ray bursts are a stark reminder of the universe's volatility and the fragility of life as we know it. These events are rare, with the odds of one directly hitting Earth being extremely low. Yet, their existence underscores the immense forces at work in the cosmos, forces capable of reshaping galaxies and ending entire civilizations in mere moments. With this glimpse into the universe's deadliest explosions, we now shift our focus to another enigma that challenges our understanding of space and time, a mysterious anomaly that some believe could hold the key to alternate realities, the cold spot in the cosmic microwave background. Moving forward, we arrive at the enigma of the cold spot, a baffling feature in the cosmic microwave background, which is the faint glow of radiation left over from the Big Bang. This region stands out as significantly cooler than its surroundings, a deviation that has puzzled scientists for decades. Stretching across nearly 1 billion light-years, the cold spot is not only vast but also defies the uniformity expected in the early remnants of our universe. So, what could explain this chilling anomaly? Some researchers propose that a massive void in the universe, an area with far fewer galaxies than usual, is the culprit. This so-called supervoid could disrupt the flow of radiation passing through it, causing the lowered temperature we observe. However, even this explanation struggles to fully account for the cold spot's size and impact. Others suggest far more exotic possibilities, including the tantalizing idea that the cold spot might be evidence of a collision between our universe and another, an interaction that could point to the existence of a multiverse. Imagine if this patch of coldness represents a bruise left behind from the clash of two separate cosmic realms. While this theory ventures into the realm of the speculative, it opens up profound questions about the very nature of reality and the boundaries of our universe. Despite years of study and debate, the cold spot remains one of the most unsettling mysteries in cosmology. Its origins could redefine what we know about the universe's structure, its history, and perhaps even its neighbors. As we ponder this cosmic riddle, we turn our attention to another marvel of the universe, an object born from extreme density and unimaginable gravitational forces, the neutron star. With the next phase of the journey in sight, we encounter one of the most extraordinary remnants of a star's life, the neutron star. When a massive star exhausts its fuel and succumbs to gravity in a spectacular explosion known as a supernova, its core collapses into an object of unimaginable density. A neutron star is so dense that a single teaspoon of its material would weigh as much as a mountain here on Earth. These stellar corpses are compact, typically spanning only about 10 miles in diameter, yet their mass can exceed that of our Sun. This extreme density crushes matter to the point where protons and electrons merge, leaving behind an object composed almost entirely of neutrons. But the bizarre nature of neutron stars does not end there. They possess immense gravitational forces that warp the very fabric of space-time around them. Their surfaces are scorching hot, often glowing at over 1 million degrees, while their outer layers are harder than any material known to humanity. Some neutron stars rotate at astonishing speeds, completing hundreds of rotations per second, which causes them to emit pulsating beams of radiation. These rapidly spinning neutron stars are known as pulsars, acting like cosmic lighthouses that send rhythmic signals across the galaxy. Even more terrifying are their rare and highly magnetic cousins, the magnetars. The magnetic fields of these objects are so intense that they could erase the magnetic strips on a credit card from a distance greater than the Moon's orbit. A magnetar's incredible power can trigger bursts of high-energy radiation that could wreak havoc on anything unfortunate enough to be caught in its vicinity. Just imagine a magnetic field so strong it could deform atoms and disrupt molecular bonds. This is the raw, destructive force of a magnetar. The study of neutron stars pushes the boundaries of our understanding of physics, challenging our knowledge of matter in its most extreme state. These objects provide a unique laboratory for exploring the limits of nature, from quantum mechanics to relativity. And yet, despite decades of discovery, neutron stars continue to surprise us with their mysteries. As we leave behind these dense and haunting remnants, we turn our eyes to the relentless stretching of space itself, a phenomenon that reveals the ever-expanding nature of our universe. With the next phase of the journey in sight, we focus on the ever-expanding nature of our universe, a phenomenon that has baffled scientists and redefined our understanding of space. At the heart of this cosmic expansion lies a mysterious force known as dark energy. This enigmatic element is believed to make up nearly 70% of the universe, yet we know almost nothing about its true nature. What we do know, however, is that dark energy is driving galaxies apart at an accelerating pace, stretching the very fabric of space-time itself. Imagine placing dots on a balloon and then inflating it, watching the dots move away from each other as the surface expands. This is a simplified analogy of how the universe behaves, though on an incomprehensibly larger scale. It is not the galaxies themselves that are moving, but the space between them that is growing. The implications of this phenomenon are both fascinating and unsettling. Over billions of years, this relentless expansion could push galaxies so far apart that they would fade from our view, leaving the night sky virtually empty except for our own Milky Way and its closest neighbors. This future, often referred to as the cosmic dark age, would mean a universe where distant galaxies and their light are no longer accessible, severing potential connections to countless cosmic wonders. Even more chilling is the idea that one day, the universe might become so vast and stretched that stars could no longer form, leaving behind a cold, dark void. The discovery of this accelerating expansion was made in the late 1990s when astronomers studying distant supernovae noticed that they were dimmer than expected, suggesting that the universe's growth was speeding up, not slowing down as previously thought. This revelation earned them a Nobel Prize in physics and opened up a Pandora's box of questions about the ultimate fate of the cosmos. Will the universe continue expanding forever, growing colder and lonelier with each passing millennium? Or could this acceleration slow, leading to a dramatic reversal where the universe collapses back in on itself in a fiery, big crunch? The answers remain elusive, shrouded in the mystery of dark energy and the very fabric of reality. This unstoppable stretching of space-time serves as a humbling reminder of how vast and complex our universe truly is. It challenges the limits of human understanding and raises profound questions about the nature of existence and the ultimate destiny of all that we know. As we venture further into these cosmic enigmas, our next step is to explore the invisible forces that seem to puppeteer the universe itself, dark matter and dark energy, and the unsettling grip they hold over the cosmos. Now turning to the invisible forces that govern the cosmos, we face the profound mysteries of dark matter and dark energy, two enigmatic elements that together constitute about 95% of the universe. Yet, despite their overwhelming dominance, their true nature remains one of the greatest puzzles in modern science. Let us begin with dark matter, an unseen substance that neither emits nor absorbs light, making it undetectable through conventional means. Scientists infer its existence by observing its gravitational effects on visible matter, such as stars and galaxies. Without dark matter's unseen mass, many celestial structures would lack the gravitational pull needed to hold together. Imagine spinning a ball attached to a string. Without the tension in the string, the ball would fly off. Similarly, dark matter acts as the invisible string that keeps galaxies intact as they spin. Still, no one has directly observed or pinpointed what dark matter truly is, leaving a vast gap in our understanding. Dark energy, on the other hand, is the force believed to be driving the universe's accelerated expansion, as we touched on earlier. If dark matter is the glue that binds, then dark energy is the force that tears apart. What makes dark energy so unsettling is its seemingly opposite effect on the cosmos. It fights against gravity, the very force that holds galaxies, stars, and planets together. This cosmic tug-of-war raises alarming questions. Could dark energy one day overpower gravity entirely, unraveling the universe as we know it? While some theories suggest that dark energy is a property of space itself, others speculate it might be tied to unknown dimensions or even a fundamental flaw in our understanding of physics. The truth is, we are venturing into uncharted territory where our existing knowledge falters. The interplay between dark matter and dark energy creates a universe that is both beautifully intricate and deeply mysterious. Together, they shape the cosmic stage, influencing everything from galaxy formation to the fate of the universe itself. Yet their elusiveness challenges the limits of human comprehension, prompting us to continuously question whether we might one day uncover their secrets or if these forces will forever remain beyond our grasp. As we ponder these invisible puppeteers and their control over the cosmos, the journey leads us to another realm of theoretical possibility: white holes, the hypothesized reverse of black holes, and what they could mean for the fabric of reality. Now turning to the concept that flips one of the universe's most feared phenomena on its head, we explore the idea of white holes, the theoretical opposites of black holes. While black holes are infamous for their inescapable pull, where not even light can flee their grasp, white holes are imagined as cosmic objects that cannot be entered from the outside. Instead of swallowing everything in their path, they eject matter and energy outward, creating a stark contrast to their voracious counterparts. If black holes are entrances from which nothing returns, white holes could be thought of as exits, spewing out material in ways that defy our current understanding of physics. This concept stems from solutions to Einstein's equations of general relativity, which suggests such objects could exist under specific conditions. But the question arises, do white holes actually exist, or are they just mathematical curiosities? So far, no white holes have been observed, leaving many scientists to believe they may only be theoretical constructs with no basis in reality. Yet, if proven to exist, their implications would be mind-bending. Imagine a portal-like entity that ejects everything but offers no way back, in almost like a cosmic fountain flowing endlessly outward. Some theorists have even speculated that white holes might be connected to black holes, forming a bridge of sorts through space-time, often likened to the concept of a wormhole. This idea opens the door to tantalizing possibilities, like shortcuts through the universe or even connections to other dimensions. However, the lack of evidence for white holes also raises doubts about their plausibility. The chaotic forces in our universe, from gravity to particle interactions, would likely destabilize any such structure almost instantly. Even so, the thought of white holes challenges us to rethink what we believe about space, time, and the universe's most extreme phenomena. As we push the boundaries of our imagination, we are reminded that the universe is as much a realm of questions as it is of answers. And speaking of questions, one of the most puzzling signals from the cosmos brings us to our next topic, the mysterious WOW signal and other potential calls from alien civilizations. Now turning to one of the most intriguing mysteries ever detected from the cosmos, we delve into the enigmatic WOW signal, a fleeting yet profoundly captivating burst of radio energy detected in 1977 by a radio telescope in Ohio. The signal lasted a mere 72 seconds, but contained such unusual characteristics that it instantly captured the imagination of scientists and enthusiasts alike. Its name, the WOW signal, originates from the astonished handwritten notation made by astronomer Jerry Amon when he first noticed the data. To this day, it remains one of the most compelling yet unexplained phenomena in the search for extraterrestrial intelligence. So, what made this signal so extraordinary? Unlike random cosmic noise that fills the universe or signals from known celestial objects, the WOW signal exhibited properties consistent with an artificial origin, something that seemed intentional rather than natural. It was narrowband, highly focused, and came from a region of space where no known stars or planetary systems exist, leading to intense speculation about its source. Could it have been a message from an advanced alien civilization attempting to reach out across the vast distances of space? Some theorists suggest that the signal might have been a ping from a distant extraterrestrial society testing its own technology. Others argue it could have been an accidental leak of their communications, much like humanity's early radio broadcasts. However, skeptics propose alternative explanations, pointing to the possibility of interference caused by a human-made satellite, an unknown cosmic phenomenon, or even a one-time natural event we are not yet equipped to understand. Yet, despite years of investigation, the WOW signal has never been replicated or traced to its origin, adding to its mystique and the ongoing debates about its true nature. But the WOW signal is not alone in its mystery. Over the years, astronomers have discovered other unexplained space phenomena that similarly defy easy classification. Fast radio bursts, for instance, are sudden, intense pulses of radio waves lasting just milliseconds, originating from billions of light years away. While some are thought to result from cataclysmic cosmic events like neutron star collisions, others remain enigmatic, sparking speculation ranging from exotic astrophysical processes to alien activities. These occurrences remind us of how little we truly understand about the vast and complex universe around us. Whether the WOW signal was an intentional message or an extraordinary coincidence, it challenges our assumptions and keeps the search for extraterrestrial intelligence alive and thriving. As we ponder whether we are alone in the universe or part of a cosmic community yet to be discovered, we must also confront another deeply unsettling possibility, the Great Filter. Why, despite the seemingly infinite stars and planets, have we found no conclusive evidence of intelligent life elsewhere? Could the answer lie in an obstacle so insurmountable that it prevents civilizations from thriving or enduring? Now turning to one of the most thought-provoking concepts in the search for extraterrestrial intelligence, we encounter the Great Filter, a chilling hypothesis rooted in the Fermi paradox. The Fermi paradox, named after physicist Enrico Fermi, questions why we have not yet detected signs of intelligent alien life despite the staggering number of stars and potentially habitable planets in our galaxy alone. With billions of worlds that could theoretically host life, why does the universe remain so eerily silent? The Great Filter offers a grim potential answer, suggesting that somewhere along the path of development, from simple organisms to advanced civilizations capable of interstellar communication, there exists a nearly insurmountable barrier, one that prevents intelligent life from progressing or surviving long enough to make contact. This barrier could exist at various stages of evolution. On one hand, it might lie in the origins of life itself. Perhaps the transition from simple molecules to self-replicating organic systems is so incredibly rare that it has only ever happened once, in other words, here on Earth. On the other hand, the Great Filter could be lurking further along the evolutionary timeline. It could manifest in the form of catastrophic challenges that hinder civilizations from advancing beyond a certain point. These could include self-destruction through nuclear war, the collapse of ecosystems from resource exploitation, or even the advent of technologies that spiral out of control. If such a filter awaits all advanced civilizations, it might explain why the cosmos appears devoid of intelligent life. Those who reach a certain stage inevitably fail to survive. But what if the Great Filter is not behind us but ahead of us? This unsettling idea suggests that humanity has yet to encounter the ultimate test of survival, a gauntlet through which no civilization before us has passed. It casts a shadow over our future, raising questions about the choices we make as a species and the fragility of our existence in an unforgiving universe. While the Great Filter may seem like a disheartening concept, it also serves as a powerful reminder of the responsibility we carry to protect our planet, manage our technologies wisely, and foster global cooperation. After all, if we aim to transcend this potential barrier, understanding its implications could be key to ensuring our survival. As we wrestle with the possibility of humanity's place in a universe filled with silent stars, we turn to yet another compelling enigma: the event horizon of black holes and the unrelenting pull into the unknown. What truly happens beyond the point of no return? Now turning to the enigmatic boundaries of black holes, we arrive at the event horizon, the point of no return. A black hole's event horizon marks the invisible threshold where the gravitational pull becomes so overpowering that nothing, not even light, can escape. It is the ultimate barrier, a boundary that separates what we can observe from what becomes permanently lost to the void. Imagine a place where the fabric of space and time is stretched to its breaking point, where every known law of physics ceases to apply. Crossing the event horizon means leaving behind everything we understand about reality and entering a realm of incomprehensible extremes. For anything that ventures too close, the journey toward the event horizon is both surreal and terrifying. To an outside observer, time appears to slow down for the unfortunate object as it approaches the edge, due to the intense warping of space-time caused by the black hole's gravity. The object would seem to freeze in place, its image fading into an eerie red glow before vanishing entirely. This effect, known as gravitational time dilation, is a bizarre glimpse into how black holes distort not just space but time itself. Yet, for the object crossing the threshold, the experience would be altogether different. It would plunge into the black hole without perceiving any distinct boundary, falling helplessly toward the singularity, where the mass of the black hole is concentrated into an infinitely dense point. The sheer terror of the event horizon lies not only in its inescapability but in the mysteries that lie beyond. What happens to matter, energy, or even information that falls into a black hole? Does it vanish forever, or is it somehow preserved in ways we cannot yet comprehend? These questions have puzzled scientists for decades, sparking debates about the fundamental nature of reality itself. Some theories suggest that information falling into a black hole could be stored on its surface, encoded in a way that defies our understanding of physics. Others propose that black holes may serve as portals to other parts of the universe or even alternate dimensions, though these ideas remain purely speculative. The event horizon is a stark reminder of the universe's capacity for extremes, a boundary that challenges our grasp of the cosmos and reveals how little we truly know. While it stands as one of the most fascinating and fearsome phenomena in existence, it also serves as a testament to humanity's relentless curiosity. Even as we confront the terrifying unknown, the desire to understand what lies beyond continues to drive our exploration. Moving forward, we leave the unfathomable depths of black holes behind and turn our attention to a different kind of cosmic terror: the looming shadows of immense space clouds where beauty and destruction intertwine. With the next phase of the journey in sight, we now set our focus on the colossal space clouds lurking in the vastness of the cosmos. Among these, the towering pillars of creation stand as one of the most iconic and mesmerizing sights captured by human technology. These massive structures, located in the Eagle Nebula, are composed of dense molecular gas and dust, creating stellar nurseries where new stars are born. Their beauty is undeniable, with intricate details illuminated by the surrounding starlight, offering a glimpse into the grandeur of our universe. However, beneath this awe-inspiring facade lies a darker, more destructive reality. Giant molecular clouds like the pillars of creation are hotbeds of violent activity. Deep within their dense regions, gravity begins to pull matter together, initiating the fierce process of star formation. This collapse generates intense heat and pressure, igniting the nuclear reactions that give birth to new stars. Yet, this process is far from peaceful. Surrounding areas are often bombarded with shock waves and intense radiation from nearby young stars, which can carve out enormous cavities in the cloud, disrupting its structure and creating chaotic turbulence. Entire regions within these clouds may be torn apart, scattering material across space before it has the chance to coalesce into stars. The destructive forces at play within these clouds are not limited to stellar winds and radiation. Massive supernova explosions triggered by the death of larger stars can send powerful shock waves through the surrounding areas, obliterating parts of the cloud and initiating further cycles of chaos and creation. This cycle of destruction and rebirth is a stark reminder of the violent processes that shaped our universe and continue to do so. While these events may seem distant and removed from our everyday lives, they hold profound significance. They are the very processes that forge the elements necessary for life as we know it. Despite their seemingly eternal nature, even the pillars of creation themselves are not immune to the relentless forces of the cosmos. Astronomers believe that these stunning formations may have already been destroyed by a supernova thousands of years ago, with the light of this destruction yet to reach Earth due to the immense distances involved. If true, it would mean that what we see when gazing at these magnificent structures is not their present state, but a ghostly echo of their past. These space clouds, with their duality of beauty and turmoil, remind us of the universe's ability to simultaneously create and destroy. They challenge us to look beyond their picturesque appearances and understand the raw, untamed forces at work. As we leave behind the enigmatic allure of these cosmic nurseries, we shift our gaze to another celestial phenomenon that defies comprehension: the phenomenon of zombie stars, where death is not the end but the beginning of something far more explosive. As the next challenge unfolds, we dive into the eerie phenomenon of zombie stars, a cosmic event where death becomes a rebirth of catastrophic proportions. These are a specific type of supernova known as Type Ia supernova, and they begin with a star that has already reached the end of its life. After exhausting its nuclear fuel, the star collapses into a dense white dwarf, a remnant that would typically signify the end of its stellar story. Yet, under the right conditions, this remnant can defy its fate and return to a terrifying second act. This resurrection occurs when the white dwarf is part of a binary system, a pairing of two stars bound by their shared gravity. If the companion star ventures too close, the white dwarf begins to siphon material from its partner, slowly stealing hydrogen and helium from its surface. Over time, this stolen mass accumulates, and as the white dwarf grows heavier, it approaches a critical point known as the Chandrasekhar limit, the maximum mass a white dwarf can sustain. Once this threshold is crossed, the core becomes unstable, triggering a thermonuclear explosion so powerful that it outshines entire galaxies. The sheer energy unleashed during a Type Ia supernova is almost incomprehensible. In an instant, the star obliterates itself, releasing radiation and matter at speeds reaching millions of miles per hour. This explosion is not just destructive, it is deadly. The intense burst of light and energy can devastate its cosmic neighborhood, stripping nearby planets of their atmospheres and sterilizing any chance of life. For astronomers, these explosions also serve as critical tools for measuring vast cosmic distances, as they emit a predictable light that acts like a celestial yardstick. But the legacy of these zombie stars extends even further. In their explosive finale, they scatter heavy elements such as iron and nickel into the surrounding space. These elements, forged in the heart of a star and released through its violent demise, are the building blocks for planets and even life itself. In this way, zombie stars, despite their destructive nature, play a vital role in the ongoing cycle of cosmic creation and destruction. As fascinating as they are horrifying, zombie stars remind us of the universe's capability to transform death into a new beginning, albeit through violent and chaotic means. With this unsettling phenomenon leaving us in awe, we now step forward to examine the perplexing ways in which the flow of time itself can be stretched and warped under the immense gravitational forces of the cosmos. With the next phase of the journey in sight, we delve into the mind-bending concept of time dilation, where the very fabric of time itself can warp and stretch under immense gravitational forces. Much like a river flowing at different speeds depending on its depth and obstacles, time is not an unchanging constant, but rather a flexible dimension shaped by the gravity of massive cosmic entities like black holes. Imagine being near a black hole, an object so dense and heavy that its gravitational pull distorts time, causing it to slow down for anything caught in its grip. Someone standing far from this gravitational monster would experience time passing much more quickly compared to someone close to it. To put it simply, a few minutes spent near a black hole could equate to years or even decades in the rest of the universe. This phenomenon is not just a theoretical idea but a proven reality based on Einstein's theory of relativity, which describes how time and space are interconnected. One of the most extreme examples occurs near the event horizon of a black hole, the point beyond which nothing can escape, not even light. Here, the gravitational pull is so intense that time stretches infinitely. If you were to observe someone falling toward a black hole, you would see their movement appear to slow until they almost freeze in time, all while they continue to experience time at its normal pace. This eerie effect creates a strange disconnect between perception and reality, a reminder of just how different the rules of the universe can be from our everyday experiences. The implications of time dilation extend beyond black holes. For instance, astronauts aboard high-speed spacecraft or those on long missions experience time slightly differently from people on Earth, aging just a fraction less than their counterparts on the planet. Although the difference is minuscule in such cases, it is a striking demonstration of how even small variations in speed or gravity can alter the passage of time. Now, imagine a scenario where someone ventured close to a supermassive black hole, witnessing the universe evolve in rapid motion. Stars would be born, live out their lifespans, and die before their eyes in what felt like mere moments. Galaxies would shift and transform, and the fabric of the cosmos would unfold its story at an unimaginable pace. Such a perspective would offer a chilling glimpse into the fleeting nature of time and our place within the grand, ever-changing universe. Time dilation forces us to rethink everything we know about time. It is not the steady ticking of a clock, but a dynamic, malleable force that bends to the will of gravity and speed. As we continue to explore these distortions, we uncover a universe that defies logic and embraces complexity, where time is both a measurement and a mystery. Moving forward, we turn our attention to quasars, the dazzling yet destructive mega-lighthouses of chaos that illuminate the distant corners of the cosmos with their extraordinary power. With the next phase of the journey in sight, we shift our focus to quasars, the extraordinary mega-lighthouses of the cosmos that mark the centers of distant galaxies. These incredibly bright and powerful phenomena are fueled by supermassive black holes, voracious cosmic engines that consume surrounding matter with insatiable hunger. As gas and dust spiral into the black hole's gravitational grip, they form an accretion disk, a whirling maelstrom of material heated to unimaginable temperatures. It is this extreme heat that generates the staggering luminosity of quasars, making them visible across billions of light years. To put their brilliance into perspective, a single quasar can outshine an entire galaxy, radiating energy equivalent to trillions of stars combined. But the dazzling light of quasars belies their violent and destructive nature. The process that powers these cosmic beacons is anything but serene. As matter swirls toward the black hole, it is subjected to immense friction and gravitational forces, releasing jets of energy that can travel at nearly the speed of light. These jets, bursting outward from the quasar's poles, can stretch thousands of light years into space, unleashing radiation so intense that it can sterilize entire regions of the surrounding galaxy. Planets caught in the path of a quasar's energy beam could see their atmospheres stripped away, leaving behind barren, lifeless worlds. Even distant star systems are not immune to the destructive influence of these high-energy jets, which can reshape entire galaxies over time. Quasars also serve as cosmic historians, offering a glimpse into the early universe. Most quasars are found at immense distances from us, meaning their light has traveled for billions of years to reach Earth. By studying them, astronomers can piece together the story of the universe's evolution, from its chaotic infancy to the structured cosmos we observe today. They reveal clues about the formation of galaxies, the growth of supermassive black holes, and the dynamic processes that shaped the universe on the grandest scales. Yet, for all their scientific value, quasars remain deeply unsettling. They remind us of the raw, untamed power lurking in the depths of space, a power that can both illuminate the cosmos and obliterate everything in its path. As we marvel at their brilliance, we cannot ignore the chaos they leave behind. Moving forward, we explore the growing human-made threat of space debris and the looming danger it poses to future exploration, a problem known as the Kessler syndrome. Now turning to the next challenge, we descend from the cosmic scale of quasars to a problem much closer to home, one born from humanity's growing presence in space. The Kessler syndrome describes a terrifying scenario where the accumulation of space debris in Earth's orbit reaches a critical point, creating a chain reaction of collisions. Imagine countless fragments of defunct satellites, spent rocket stages, and other debris crashing into one another at orbital speeds. Each collision generates even more debris, further increasing the likelihood of subsequent impact. This cascading effect could, in time, render Earth's orbit so clogged with dangerous fragments that space travel becomes not just risky, but virtually impossible. But this is not merely a theoretical issue. Already, there are tens of millions of pieces of debris orbiting Earth, ranging from tiny paint flecks to entire derelict satellites. Traveling at speeds exceeding 17,000 miles per hour, even the smallest shard can cause catastrophic damage to active spacecraft. This growing cloud of orbital junk threatens functioning satellites that power essential technologies like weather forecasting, global communication, and GPS systems. A single collision could disrupt these services, impacting life on Earth in ways we can scarcely prepare for. The implications for future exploration are equally dire. If the chain reaction predicted by the Kessler syndrome were to occur, launching new missions to space could become too dangerous. Human access to the stars would be effectively blocked, leaving us stranded on our planet. The dreams of reaching Mars, exploring distant moons, and unlocking the mysteries of the universe beyond Earth would be extinguished, all because of the mess we left behind in orbit. Efforts are underway to address this escalating issue. Emerging technologies aim to remove debris from orbit, while stricter regulations are being proposed to ensure new satellites are designed with disposal plans. However, the challenge is immense and time is of the essence. The Kessler syndrome is a sobering reminder that the wonders of space exploration come with responsibility, a lesson we must heed if we are to preserve the cosmos as a realm of discovery rather than destruction. As we grapple with this looming threat, we turn our gaze back to the early whispers of the universe itself, a place where the echoes of the Big Bang still resonate. As the next phase of the journey unfolds, we dive into the faint, ancient whispers of the cosmos that still echo across the vast expanses of space. The cosmic microwave background is a haunting remnant of the Big Bang, a faint glow that permeates the universe and offers a window into its earliest moments. Stretching back nearly 14 billion years, this radiation is the oldest light we can observe, carrying within it a story of creation, expansion, and evolution. Discovered in the mid-20th century, the cosmic microwave background provides scientists with a detailed map of the universe's infancy. Tiny fluctuations in its temperature reveal the seeds of cosmic structure, the minute differences in density that eventually gave rise to galaxies, stars, and planets. These ripples, frozen in time, whisper secrets of how the universe grew from a hot, dense state to the sprawling expanse we see today. Through sophisticated telescopes and careful analysis, researchers have pieced together a remarkably precise account of the universe's age, composition, and rate of expansion, all derived from this faint yet invaluable light. Yet the cosmic microwave background is far from being a perfect canvas. Strange anomalies persist that some argue could hint at phenomena beyond our current understanding. One of the most perplexing is the cold spot, a cooler-than-expected region that has sparked intense debate in the scientific community. Could it be evidence of a massive cosmic void, or even the imprint of another universe brushing against our own? These unanswered questions remind us that, even with all we've uncovered, the universe still guards its deepest truths closely. Each glance at the cosmic microwave background not only reveals more about the past, but also challenges our comprehension of the universe's vast complexity. It stands as a testament to humanity's ability to peer into the darkest corners of existence and uncover light, both literal and figurative. With this glimpse into the echoes of the Big Bang, we now turn our attention to star systems that have long since gone quiet, where the haunting silence of dead worlds awaits. Now turning to the next chapter of our exploration, we arrive at the eerie silence of dead star systems, a haunting tableau revealed by the groundbreaking observations of the Kepler telescope. Designed to uncover planets beyond our solar system, Kepler's gaze extended deep into the Milky Way, revealing countless star systems that once pulsed with vibrant energy. Yet, among these findings, there emerged a chilling undercurrent: systems where planets may have once thrived but now remain hauntingly quiet, devoid of life, motion, or light. These celestial graveyards evoke images of apocalyptic events where stars burned out, leaving their planetary companions in cold, eternal darkness. Imagine worlds that may have once teemed with life, now reduced to desolate, frozen landscapes orbiting lifeless suns. In some cases, evidence suggests these systems met their doom through catastrophic supernovas, where a dying star's final moments obliterated everything in its vicinity. In others, planets may have been scorched by the gradual swelling of their host stars into red giants, leaving behind barren, charred remnants. There are even scenarios where celestial neighbors collided, creating chaos and destruction on an unimaginable scale. Whatever the cause, these systems stand as solemn monuments to the transient nature of cosmic existence. What makes these dead systems even more unsettling is the possibility that some may have once harbored intelligent life. Did these civilizations, if they existed, fall victim to cosmic forces beyond their control, or did they sow the seeds of their own destruction? The silence we now observe offers no answers, only questions that stretch across the void. As we study these star systems, we cannot help but wonder if humanity too might one day leave behind such a legacy, a quiet, forgotten fragment of a once living world. With the data gathered by Kepler, astronomers continue to piece together the stories of these long-dead systems, seeking to understand the forces that led to their demise. By studying them, we gain insights not only into the universe's past but also into the fragile future of our own corner of the cosmos. And as we leave these ghostly ruins behind, we turn our gaze to a terrifying possibility that could one day shatter the very fabric of reality itself, a concept known as false vacuum decay. As the next phase of the journey unfolds, we confront a chilling possibility that challenges the very fabric of our universe, a concept known as false vacuum decay. To understand this, we must first grasp a fundamental idea in physics. The vacuum of space is not simply empty, but instead a sea of energy with its own delicate balance. Our universe as it exists today might reside in what scientists call a false vacuum, a state that is stable but not the most stable it could be. Imagine a ball resting in a shallow valley. It appears secure, but with enough disturbance it could roll into a deeper, more stable valley. This deeper valley represents the true vacuum, and the transition from false to true could have catastrophic consequences on a cosmic scale. If such a transition were to occur, the effects would ripple through the universe at the speed of light, triggering a chain reaction that would fundamentally alter the very nature of reality itself. Every particle, every atom, and every form of matter and energy would be redefined or possibly erased in an instant. The very laws of physics that govern our universe could change, rendering the cosmos unrecognizable and uninhabitable. The terrifying part, because this event would move at the speed of light, we would have no warning. One moment, existence as we know it, the next, an incomprehensible transformation. What might cause such an apocalyptic event? Some theories point to high-energy phenomena, such as the collisions of particles in the universe's most extreme environments. Even advanced experiments conducted by intelligent civilizations, like the creation of high-energy particles in powerful accelerators, could theoretically set this chain reaction into motion. However, physicists assure us that the energy levels currently achievable on Earth are far too low to trigger such an event. Still, the mere possibility that a simple disturbance could lead to the universe's instantaneous and total annihilation is enough to send shivers down the spine. Despite its grim implications, false vacuum decay remains a thought experiment, a theoretical concept derived from our best understanding of quantum fields and cosmic stability. It challenges us to probe deeper into the fundamental nature of the universe, pushing the boundaries of what we know. Yet, as we consider this unsettling idea, one truth becomes clear. The universe is far more complex, fragile, and mysterious than we can fully comprehend. Moving forward from this daunting hypothetical, we turn our attention to another cosmic phenomenon, one that embodies chaos and energy on an unprecedented scale. The hypernova, the colossal sibling of the supernova. As the next challenge unfolds, we venture into the realm of one of the universe's most extreme and awe-inspiring events, the hypernova. If you thought a supernova was powerful, imagine an explosion that releases up to 10 times the energy, capable of outshining entire galaxies for brief moments. Hypernovas are the cataclysmic result of massive stars, far larger than our Sun, reaching the end of their life cycle. When such a star collapses under its own immense gravity, it sets off a chain reaction so violent that it tears the star apart, leaving behind either a black hole or a rapidly spinning neutron star. The energy unleashed during a hypernova is almost unimaginable. In just seconds, it can release more energy than our Sun will emit over its entire lifespan of billions of years. But what makes hypernovas truly terrifying is their potential to generate intense gamma-ray bursts, the most powerful explosions in the universe. These bursts send highly focused beams of deadly radiation across vast stretches of space, posing a lethal threat to anything unfortunate enough to lie in their path. If a gamma-ray burst were directed toward Earth from a relatively close distance, it could strip away our planet's atmosphere and obliterate all forms of life in an instant. Hypernovas occur in only a fraction of the universe's most massive stars, making them rare but incredibly consequential. Scientists continue to study these phenomena to understand their role in shaping the cosmos. They are thought to play a major part in scattering critical elements such as iron and gold into space elements that eventually form planets, stars, and even life itself. However, despite their contributions to cosmic evolution, the sheer destructive power of a hypernova reminds us of the chaotic and violent processes that underpin the universe. As we reflect on the raw energy and destruction of a hypernova, it becomes clear that the cosmos is filled with forces beyond our comprehension, forces that can both create and annihilate in ways that defy human understanding. With this in mind, we now step into the eerie stillness of the galactic graveyard, where remnants of star systems reveal the silent echoes of a once vibrant past. With the next phase of the journey in sight, we find ourselves drifting into the haunting expanse of the galactic graveyard, a realm where the light of stars has faded, leaving behind a silent void. These dead zones of space represent the final stage in the life cycle of star systems, where fuel has long been exhausted and the vibrant glow of young stars has given way to cold, dark remnants. Here, ancient white dwarfs, dimly glowing neutron stars, and the faint traces of scattered elements are all that remain of what were once thriving celestial communities. These areas are a stark reminder of the universe's relentless march of time, where creation is inevitably followed by decay. In these graveyards, we see evidence of the immense forces that shaped galaxies billions of years ago. Supernova remnants, clouds of dust, and faint gas filaments stretch across the void like forgotten whispers of cosmic events. These remnants hold valuable clues about the past, containing the building blocks of heavy elements like carbon, oxygen, and iron, which are essential for the formation of new stars, planets, and even life. It is in this endless cycle of death and rebirth that the universe constantly renews itself, transforming the echoes of destruction into the seeds of creation. The galactic graveyard also reveals the eerie stillness of space. Unlike the bustling, active regions where stars are born and planets circle their suns, these zones are marked by quiet desolation. The absence of heat and light creates an atmosphere of profound isolation, where the silence seems almost tangible. For any space traveler, venturing into these regions would be like wandering through a ghost town, filled with the remnants of a once lively community now frozen in time. Even in their desolation, these dead zones have a story to tell. They remind us of the transient nature of existence in the cosmos, that even the mightiest stars and most magnificent galaxies are subject to the unyielding forces of time and entropy. As we drift through this silent graveyard, the remnants left behind offer a glimpse into the events that shaped the universe into what we see today. These remnants serve as both a warning and a promise, highlighting the fleeting beauty of life while hinting at the endless possibilities of renewal. With the echoing silence of this galactic graveyard etched in our minds, we now leave behind the remnants of the past and turn our gaze toward the unfathomable vastness of intergalactic space, a domain of unimaginable isolation and darkness where even the faintest traces of life are but distant memories. With the next phase of the journey in sight, we turn our attention to the most desolate stretch of the cosmos' intergalactic space. This is the unthinkably vast expanse of darkness that lies between galaxies, a domain so empty that even the faintest whispers of matter are rare. It is a region where isolation takes on new meaning, as the distances between stars and planets grow so immense that they seem almost infinite. For any space traveler, venturing into this abyss would be like sailing into an endless ocean with no horizon, no landmarks, and no hope of finding a shore. The darkness here is not just the absence of light. It is a void so profound that even the gravitational pull of galaxies begins to weaken, leaving only the faint presence of distant starlight to hint at the existence of anything beyond. What makes intergalactic space so haunting is its unparalleled emptiness. Unlike the comparatively lively regions within galaxies, where stars cluster together and cosmic phenomena unfold, the spaces between galaxies are starkly devoid of activity. Hydrogen atoms, the fundamental building blocks of matter, are so sparse that crossing even a single cubic centimeter of this space might mean encountering just a handful of them. The temperature drops to almost unfathomable lows, nearing absolute zero, as the absence of nearby energy sources leaves the space blanketed in unyielding cold. In this realm, the isolation is so complete that it challenges our very concept of what it means to exist. And yet, intergalactic space is not entirely without mysteries. Though largely empty, it is crisscrossed by faint, nearly invisible threads of matter known as the cosmic web. These filaments, composed of tenuous gas and dark matter, stretch across the void like gossamer threads, binding galaxies together in a grand cosmic structure. This hidden network, though barely perceptible, holds the key to understanding the large-scale architecture of the universe. It is a reminder that even in the darkest desolation, there is an underlying order, a fragile connection that ties together the seemingly infinite void. For humanity, imagining a journey through intergalactic space is both exhilarating and terrifying. In these uncharted regions, the concept of home becomes meaningless as the nearest star systems would be hundreds of thousands or even millions of light years away. The isolation would be so complete that it might feel as though the universe itself has abandoned you. But in this vast nothingness, there is also a profound kind of beauty, a humbling reminder of the scale of existence and the smallness of our place within it. As we drift through this boundless blackness, we are left with an overwhelming sense of awe for the universe's ability to inspire both wonder and fear in equal measure. With the chilling emptiness of intergalactic space enveloping our thoughts, we now turn our attention to the ultimate question that looms over the cosmos: how will it all end? As we delve into the universe's potential ultimate fates, we confront scenarios so grand and final that they challenge the limits of human imagination. Now turning to the final and perhaps most unsettling chapter of our journey, we confront the ultimate fate of the universe itself, a question that has perplexed physicists and philosophers alike for centuries. Will the cosmos gradually fade into a cold, dark oblivion, or will it end in a fiery collapse, pulling all of existence back to a singular point? These two competing scenarios, known as the heat death and the big crunch, paint vastly different but equally chilling pictures of the universe's potential destiny. Let us first consider the heat death, often described as the most likely outcome according to current scientific understanding. In this scenario, the relentless expansion of the universe, driven by the mysterious force of dark energy, continues indefinitely. As galaxies drift farther and farther apart, the universe becomes a colder and lonelier place. Stars, the beacons of light and life, will eventually exhaust their fuel, leaving behind only dim remnants like white dwarfs, neutron stars, and black holes. Over unimaginable stretches of time, even these remnants will decay, leaving a cosmos devoid of any meaningful structure or activity. The temperature will approach absolute zero, and all forms of motion, energy, and life will cease. The universe becomes a silent, infinite void, a graveyard of what once was, where time itself seems to lose all meaning. On the other hand, the Big Crunch offers a more dramatic but equally terrifying vision. Unlike the slow decline of the heat death, this scenario envisions a cosmic collapse. If the forces of gravity were to overpower the mysterious dark energy driving the universe's expansion, the process could reverse. Galaxies would begin to hurtle back toward one another, colliding and merging in a catastrophic dance of destruction. Temperatures would skyrocket as matter compressed into an ever smaller space. Eventually, all of existence could be reduced to a singularity, a point of infinite density, not unlike the state of the universe before the Big Bang. This would mark not just the end of time and space as we know them, but perhaps also the beginning of a new cycle with the potential for another Big Bang to give rise to a new universe. Both scenarios challenge the limits of human comprehension, not just in their scale but in their implications for the nature of existence itself. Are we living in a universe destined for eternal stillness, or one fated for fiery rebirth? The truth, for now, remains shrouded in mystery, a puzzle that continues to drive scientific inquiry and philosophical reflection. What we do know is that regardless of how the universe ends, these grand and final acts serve as a humbling reminder of the impermanence of all things. They compel us to cherish the fleeting moments we have, as small and insignificant as we may seem in the grand scheme of the cosmos. As our exploration of the universe's dark side comes to a close, we are left with a profound sense of awe. From the cold void of intergalactic space to the ultimate fates of existence, the horrors and wonders of the cosmos reveal not just the universe's immense power, but also its capacity to inspire us to seek, question, and understand. The mysteries of the dark universe are not merely things to fear, but are also a call to continue our journey into the unknown, pushing the boundaries of human knowledge and imagination. Now turning to the lessons hidden within the dark universe, we find ourselves confronting truths that are as humbling as they are enlightening. These cosmic horrors, while terrifying in their scale and implications, also serve as profound reminders of our own fragility. The vastness of the universe and the forces that govern it underscore just how delicate and fleeting life truly is, a fragile spark amidst an ocean of chaos and mystery. Yet, even in the coldest voids and most violent phenomena, there exists a kind of beauty that defies explanation. The intricate dance of galaxies, the birth and death of stars, and the strange elegance of black holes point to a universe that is as artistic as it is scientific, as poetic as it is powerful. These dark wonders inspire a sense of awe that pushes us to look beyond the fear they may evoke, prompting us instead to seek understanding. They encourage us to embrace curiosity as a guiding force, reminding us that the unknown is not just a source of dread but also of endless possibility. The universe, with all its dangers and enigmas, is an open invitation to explore, to question, and to learn. It challenges us to expand the boundaries of human knowledge, driving us to innovate, to imagine, and to dream beyond the limits of our current understanding. In the face of such overwhelming vastness, we might feel small, yet this very smallness carries its own significance. We are sentient beings capable of contemplating the cosmos, capable of finding meaning and connection even in the face of the infinite. The lessons of the dark universe compel us to reconcile our insignificance with our potential, teaching us to cherish the fleeting moments we have against the backdrop of eternity. As we gaze into the depths of the cosmos, we are not just looking outward but also inward, discovering what it means to be human in a universe that is at once terrifying, beautiful, and profoundly mysterious. As we wrap up our journey through the universe's dark side, it becomes clear that these 25 space horrors are more than just terrifying phenomena. They are profound chapters in the story of the cosmos, each one revealing something extraordinary about the nature of existence. From the eerie emptiness of the Boötes Void to the cataclysmic collisions of galaxies, these mysteries shape the way we see the universe and our place within it. They remind us of the fragility of life, the power of curiosity, and the boundless depths of the unknown. These horrors are not just tales of destruction and danger, they are invitations to marvel, to learn, and to wonder. Who knows what other secrets the universe holds? Perhaps the most chilling thought is not what we know about the cosmos, but what we have yet to discover. So, as you ponder the unimaginable scale and complexity of our universe, let it inspire you to keep asking questions and seeking answers. If you enjoyed unraveling these cosmic mysteries, subscribe to our channel for more journeys into the unknown. Like the video, share it with fellow explorers, and let us know your thoughts in the comments below. Together, let us continue to explore the wonders and horrors of the universe, one mystery at a time.